Okay, so the last part of the code is the main function. So basically we are going to integrate all of these code together and implement a really simple script to process the user argument and also do some comparative analysis between the processing between the inter-process communication methods. I love this mark. So let's go implement it. So first we actually make the source file. Then as usual we include the header files that we want to use in our script. And let's also add a string, and then the dependency, our own dependencies, like common, as we used this one before. Also, let's say a domain socket. What else? Well, actually, it would be better to and then what else? Oh, the shared memory one, and that would be it. Let's do some other thing, maybe later. Perfect. And then since we want to use chrono, we rename it for easier referencing during our script. And let's go define the main. So the first one is the number of arguments that we would have when user is actually passing the argument to your program. So that's you can count on that. And then also the value of those argument that pass to your program would be here. And let's do it for now here. And then let's define a red code, and then we do something like that. And then we say, okay, define method. Then we say if argc, of course it's not efficient, it's not completely correct. We are just trying to I'm just trying to implement something that we can use to test these method. This way of calling the arguments and like parsing the arguments is not actually at all a good approach to do it. It's just for testing. So if you want to do that, we can if you let me know by your comments or direct message in my LinkedIn or anywhere else. If I see that you guys want to see how to do that, we can actually I can actually do some live coding for that too. It's really straightforward. I don't think you guys would need it. It's just really easy to implement those kind of things. And so we say, okay, the method. So if the user give the first argument that will be passed to our program, we consider it as the inter-process communication method that we want, and also the packet size. So as you can see, the method, we are directly using that input, and it's not a good way to do it. So it's better you process it and see if it's actually a correct input or not, but we don't want to do that. And it's just a number of iteration is not important. And as usual, I love adding comments and also adding descriptive in like adding information to my output, because it really helps other developers that going through your code, or you yourself, when after a while you want to see what did you do. And then if you don't add these kind of things, you're gonna have a hard time understanding what the hell did you do in that kind part of the code. So be patient, don't try to rush it, because it would be easier in a long term when you take your time and add relevant comments, and also make your output more understandable for maintaining your code, for sharing your code, and even for archiving your code for later, especially if you are like me and you work on multiple projects during the week in your workplace, in your when you get back home. Then you would need some sort of um, these correct structures and all of that, just to make sure that you you don't have to go through all part of the code again to remind yourself what did you do for a specific like function or something like that. And when you define your variables and your methods, your functions, classes in a relevant and understandable name, then it would be easier for you guys to actually understand your code better later. Now here we want to use fork just to create a child process because we need two processes to communicate to each other. So when we do fork, it return a process ID, and if this process ID is it's not like it's a non-zero value, then sorry, if it's -1, which it means that okay, this is not it failed to create the child process. So you need to let your user know that it is failed. Something like that, and then you return it. Okay, if your process ID is not 0, that means it's what the hell I'm doing? Perfect. And then we define the buffer that we want to actually keep our data in it here, and we assign this packet size that the user passed to our program. And then I'm defining a unique PTR or a pointer just to manage my pointer and make sure that I can it will be released after I'm done with it. It's really it's a good thing you use the standard library smart pointers for your applications, because when your objects when your program get bigger and bigger, managing the memory and pointers, all of that will be become a headache. Yeah. And then boost. So we say, okay, if the method is boost, then we are going to make a unique PTR. Sorry, PTR for, yeah. So I'm defining a pointer with a type of abstract IPC, our abstract class, and then I assign the shared memory I hate this auto-filling thing. It's not correct. It's always makes lots of mistakes. I don't like it. So let's say test, and then we are going to let's say server, and then packet size, and that would be it. Yeah, perfect. Else if method equal to the named pipe, I'm going to say okay. Just to make sure here. The last method we are going to use is the domain socket. Perfect. Yeah. Just yeah, just to make sure we don't raise any error. Let's problem. Perfect. So that's it. So after this, we make sure, okay, let's do one else, and then here we say, okay, method is not supported, something like that, and then return, yeah. Then now that we have this, we need to actually initialize it. So let's say let's initialize it. Perfect. Oh, sorry. Yeah. And then we say if the return of this initialization method was not equal to success, we have some error inside, so we need to actually report it to the user, something like that. And usually yeah. And then yeah, so now let's implement some variables to keep the statistics, like long, because we want to keep the how many bytes we want to write, or how many milliseconds it took to the data to be written inside and then receive the other side. Yeah, and maximum write duration, something like that. And then we want to do some iteration, and then let's say start. So we don't want to bother ourselves with defining the type of the variable that we want to use here, so you can use auto. Yeah, so here we get the current time in millisecond here, and then we do a memset, and we are actually defining some data to be broadcast or be transmitted to another process here. We define it as char since it's a single byte, and let's say something like that. It's not really something crazy. We don't want to create something really complex. We just it's very important. So when you are actually, especially when you are working on a complex problem, or you want to design a very complex system, or you are working in some deep learning or an AI algorithm, whatever, when your task is difficult, do not try to somehow create some sort of complex or some very dynamic or customizable process pipeline at the beginning. It's better you focus on the complex problem, solve it first with a simple or even stupid process pipeline, just to make sure that the actual functions that you is really important for you and you want to implement is actually correct and working. And then after that you can focus when you have a component that's working and do what exactly you want it to do, then you can focus on your process pipeline or do whatever you want. So here we want to pass the data that we created here, pass the data to the other process. Okay, here. So we check if it is successful or not, and then perfect. We do continue just to don't go through the other part of the program. Now here we want to measure how much time it took for this process to actually transmit the data. Okay. Why I put set? I don't understand. And yeah, perfect. So here we have the duration. Also, now we need to perfect. Of course, so it would be minimum duration. What the hell? Yeah. Perfect. And that would be it. Yeah, so this part is done. Now let's go for the other part. Before we go, I forget. Okay, we got these data, but we didn't print it actually somewhere, or didn't do anything. You can write a program to write it in a text file, or you can do whatever you want. I'm just writing it here. Yeah, it would be better for us to not bother ourselves to do something about it. And then, okay, here it's better we mention the unit of this value that we are presenting. Yeah, we don't have any average. Why you? I don't know. Perfect. Then okay, next part, the next thing we want to not count, see out. Why I didn't see that? Minimum write duration. We have this value again, microseconds, and then that's it. Just a simple copy paste, make it maximum. That's it. And then we do, let's say, 2-second sleep. And that's not sleep, but it's better just to make sure that everything is done. And then we terminate our in a process communication part. Perfect. Now, for the other part, which means when fork is 0, we again needs to define something. We need to define our memory block that we keep data in order to be transmitted or received. Yeah. Again, it's not at all something, it can be implemented much better. I'm just implementing really fast and I don't care for now. But while we go further, maybe in other programs, I try to make it more I try to make it in a way that when you watch it, you can actually like product grade code. Yeah, we can do that, but not for today. Was it? Yeah. So for instance, here we could use some inner function, some inner condition to make sure that we don't rewrite this method definition and all of that. So we write it only once, but again, we just here to test this method, so it's actually not something that we want to be bothered with for now. Of course, in the following days, I'm gonna prepare some videos about the design patterns, the best practices for C++, embedded C, and Python, maybe JavaScript, and then you guys can watch that and understand better what would be the best approach for different problems, and what would be the best approach to implement something, especially if you know about design patterns and how you use them in your program. I know if you think about something, you can implement a good enough approach to solve it. But when you know design patterns, the good thing is instantly you can understand, okay, for this purpose this design pattern is the best. Since all these design patterns are already tested in millions of line of code, it reduced the risk of your code, and it reduced the amount of it actually decreased um, the possible bugs in your program, and it makes your development faster. So there are a lot of good things about it. Okay, again, like the other one, we initialize it. Yeah, then we just let's copy this from here. Don't need to. Actually, these are repetitive codes, so don't do that. Yeah, don't do these kind of things. So now that I'm for the client, we want to see what is the duration of the reading. So we're going to do that. Perfect. And then again, my Python knowledge suddenly came out. I was writing in a Python format for a second. Again, like that. So no need to. I'm telling you, try to avoid repetitive code. For now, we just want to write something. So we are giving this code a data, sorry, a memory block to write the received data inside it. Perfect. And then let's do nice. Now auto start auto dinner. Yes, suddenly I lost my code, so I was looking around what the hell is going on. Yeah. Perfect. And then total read duration would be duration count, and then if minimum read duration is bigger than duration count, just replace the value with the current one, and if maximum was smaller or lower than what the current value, you just replace it. Perfect. Yeah, awesome. And then we're gonna write the things that we wrote there. Yeah, so I'm just updating some part of the code, so don't worry about it. Perfect. And then at the end, when we have the result, we just do the sleep and then terminate it. Awesome. So this is the main function. I hope you enjoyed it. I don't know whether it was something that interests you or not, but it was a really simple script. It wasn't optimal. It wasn't something that you need to do in a real program, but it was something for us to have a base for our comparative analysis, just to be able to get the result. Okay, so we have everything. Okay, thank you. Okay, so we ran the project, we ran the script, the main function, and with different message sizes, and as you can see, the iteration is the same, and these are the results. So we ran the main function for 3 different message size, and you can see that what is the message rate during this number of iteration, and what was the maximum duration of transmission of the data. So you can see here the result. As we were expected, the shared memory showed the least amount of time needed for transmitting and reading the data, and also the name pipeline was the next, and the lowest one was domain socket, as we explained before. So if we consider the minimum amount of like the data size, and we compare these 3 together, you can see the shared memory is by far faster than name pipe and domain socket. So these are the results. I hope it can be helpful for you guys, and yeah, so let's hope that you guys can use these methods in your projects, in your embedded systems, in your normal project, whatever you are working on. And if you have any question, or if you need my opinion or advice about any of these, please leave a comment, and you can subscribe to the channel if you feel like the the videos that I'm providing is useful for you guys, and hope to see you soon with another program. Thank you.